Here we have two parallel plates that are separated a distance d apart. From chapter 21, we found that the electric field between the two plates to be equal to the surface charge density over the permittivity of free space, the epsilon naught. Now recall that surface charge density is the charge over the surface area, A. So if we plug this in for sigma, we find an equation for the electric field between two parallel plates. From chapter 23, we also found that the difference in potential between these two plates can be written as the strength of the electric field times the distance between the two plates. And again, this is specifically assuming a uniform electric field, which we do have between these two plates, and that d is the distance between the two plates. Combining these two equations together, and I will do so by solving each of them for E, the electric field, I find this relationship. If I go ahead and solve for Q, the charge on one of the plates, I find it's equal to the potential difference times the permittivity of free space times the surface area of one of the plates divided by the distance between them. So this basically says that the charge on the plates is directly proportional to that potential difference. So the ratio of the charge to the potential difference is then going to be equal to the permittivity of free space times the surface area divided by the distance. This is just the geometry of the plates. So we then call this part here Q over delta V. That's called the capacitance, which we write as a capital C. And again, it's defined as the charge over the potential difference. And it depends only on the geometry of whatever your electrodes that are making up your capacitor happen to be. In this example I showed for two parallel plates, but in your textbook you can also see examples for a cylindrical capacitor and spherical capacitors. So to be completely explicit, only for a parallel plate capacitor is this true. However, this equation is the general equation for capacitance. The unit of capacitance is a farad. 1 farad is often written as a capital F, and that's defined as 1 coulomb per volt.